Okay, this is example 8, and in this example we're gonna take a look at the compare node inside of the VOP and kind of what we can do with this and how to work on the points with that. But first of all, I want to just do two things. I want to group and I want to color some points here. So let's start from the beginning. We have a sphere, we make a volume, we make points. We make 1,000 points and we want to sort them by Y. Instead of X this time, we're gonna sort them by Y. So this means that our point numbers will go from a 0 to 99 in Y direction, okay? We're not going to worry about that, but just remember that it goes from 0 to 99 in Y direction. We're going to color them blue, all of the points. So this is very important in this example. Remember that blue is 0, 0, 1. So the R is 0, the G is 0, but the blue, the B, is 1. So the vector component for this is 0, 0, 1, okay? I now want to group the points from 500 to 999, which means I'm going to group sort of the half of the points, okay? And I'm going to color these points. Instead of blue, I'm now going to change the color completely to red. And remember that the red vector values are 1, 0, 1, 0, 0, which means R equals to 1, G equals to 0, and B equals to 0. So we now have two sets of points with two different color values. Some of them are blue and some of them red. Some of them have 0, 0, 1 and some of them have 1, 0, 0. Okay, this is very important because now we want to start comparing these points. This was not, okay, never mind that, but anyway, we want to start comparing the points by the color. So let's go into the VOP. Okay, so what the compare node does, it takes two inputs, okay? So we're gonna input the color values, and we, as you remember, we have two different color values. We have 1, 0, 0 for some of the points, and we have 0, 0, 1 for some of the points. I want to do things to the points that have the value 1, 0, 0. This means that in the compare node, I want to only work on the points that is equal to 1, 0, 0. This means that I'm going to put the test to equal, which is the equal, okay? And I want them to be equal to exactly that, 1, 0, 0. So I'm going to pipe a constant to the second input with the values 1, 0, 0. Now, this compare node is going to take all the points incoming, all the color values, okay? And it's going to look and see what points here have a color attribute vector exactly equal to 1, 0, 0, okay? And what it's going to do is it's not going to like delete anything. It's not going to do anything like that. The only thing that this compare node is going to do is going to add a Boolean value to these points. And Boolean value might be like a little bit hard to understand. You can look it up on Wikipedia or whatever. But a Boolean is basically if it's a statement that if something is true or if it's false. And how Houdini kind of does this with the compare node is that if something is false, it gets the number 0. Okay? This is not an attribute that is like added or anything. It's just in this equation here in the VOP. This point gets a 0 if it's not 1, 0, 0. All the points, however, that are 1, 0, 0 gets the Boolean true, which is the number 1, okay? So imagine now that all the points come in here. All the points that are equal to 1, 0, 0, essentially all the points that are red, gets the Boolean value 1, okay? They are true. All the points that come in that are blue, that are not equal to this at all. Because the blue points, as you remember, they are 0, 0, 1, okay? They are not equal to this. That means that they get the Boolean value 0, because they are false, okay? Remember that. So we pipe the Boolean values here into an add node. And in its add node, we're going to add the constant number 1 to all of the points. And this means that we are basically, for all the red points, we are doing the math equal to 1 plus 1, okay? And for all the points that are false, the blue points, we're doing the math that is equal to 0 plus 1. And as you know, 0 plus 1 is 1, 1 plus 1 is 2. So the red points gets the value 2, the blue points gets the value 0, okay? Remember this, because now we're gonna pipe this into a multiply. And remember, the red point here now has a value of 2, while the blue point has a value of 1. And as we spoke about earlier, when we multiply, we always want to multiply anything by 1 at least, because then they keep the same position as they used to have. So we're going to pipe the position of these points, the P, into this multiply. We're going to pipe our values here. That can be either 1 or 2. 1 for the blue points and 2 for the red points. Okay? We're going to pipe that into the multiply input 2. And this means that the position of the blue points will get multiplied by 1. So they will keep their position. They will stay the same. While the red points that now has a value of 2, since we added a 1 to 1, since the red point got the Boolean value true, which is 1. So they have 2. So the multiply will therefore multiply the red points by 2. And this means the new position will be doubled. And we can see this by visualizing the VOP. Bam, there you go. The red point gets a multiplied position by 2, while the blue points stay the same. So this is just one of the many ways we can use the compare. Actually, the Boolean value is usually used with a two-way switch node, where we can switch between things. So I'm going to show you guys how that works as well. So let's say we do the same compare here. So the blue points come in. I'm just going to visualize here. The blue points come in and the red points come in. We compare them. The blue points get a false, a 0 in the Boolean value. The red points get a 1 in that is true for the Boolean value. We're going to pipe the Boolean value to the condition of the two-way switch. So the two-way switch will switch between two values compared on this condition. And the condition takes either a 0, false, or a 1, true, okay? So we're going to pipe the original position into the value 1, okay? This means that if the condition is true, the input 1 will be used. If the condition, however, is false, we're going to use the constant vector of 0, okay? So now the two-way switch will either switch between the original position or 0, 0, 0, okay? And it grabs the compare node's Boolean value, which can be 0 or 1. Let's pipe the result from two-way switch into the position. And let's visualize the VOP. And as you can see, the red ones stay the same because they grab the original position. They grab the original position since they are true in the compare. And they get a Boolean value 1, which means we switch to the input 1. That is the original position. But the blue points gets the Boolean value 0. Therefore, we switch to input 2 for those points, which is 0, 0, 0. And the result goes into the position. And as we see, the blue points are still there, but they are hardly visible since all of their values are 0, 0, 0. We can modify this to put it like this. And we can see that they are all now into this tiny little point here. But yeah, that's sort of how you can use and compare. You can use both like this, like adding things on top of it, or you can use it in a two-way switch, or you can use it in a million other ways. It's up to you. You're free to do whatever you want, but this is some of the ways you can use this compare node. Anyway, guys, thank you guys for watching this tutorial, and I see you next one.